What we are going to talk about in this video is ions, and specifically we're going to talk about how to name ions or how to write their symbols. So we're going to start off on the right-hand side on the periodic table. If you remember, that's where you will find most of the anions coming from. Love to write that word out. Anions, remember, are mostly nonmetals. You can have metals becoming anions, but it's super duper rare. We're not going to worry about that in Chemistry 1. And mostly nonmetals do this because they gain electrons very readily. All right. And when we look on the left-hand side, or on the right-hand side, excuse me, on the periodic table, remember the nonmetals are on that right side of that stair-step line. Naming anions is very easy. You have heard some of these before. To name an anion, what we do is we take the element name and we change it so that it ends in IDE. So the only trick here is seeing the pattern by which we change these element names by how we make them end in IDE. So a very common IDE ending that you've heard of before, undoubtedly, is if we look at the element fluorine. Fluorine actually has the name fluoride when it is a negative ion. And so when we look at the formula for fluoride, it's actually got this -1 up here as a superscript. That is the charge. So before we've been calculating charge, right, as a part of Penzac, the C being the charge, now we've got the charge right here in the formula for this ion. And that is fluoride. You've heard of fluoride possibly in toothpaste. And now you know what you're hearing about is a negative ion, an anion of fluorine. Other ones that you may have heard of are like Cl with a -1 charge. That is, it's not chlorine, it's got a negative charge. That is chloride. Another one you may have heard about, I know you've heard about, is when you've got oxygen with a negative charge. Oxygen with a negative charge, O-2. That is not called oxygen. Oxygen sounds dumb, so we call it oxide. And then right below that is sulfur. Sulfur with a negative charge is sulfur -2. And that is not called sulfuride, that is called sulfide. So we start to get some of the pattern here. And to keep going with that pattern, we're going to move over to the next one. The next one over is nitrogen. Nitrogen. All right, nitrogide sounds silly, so instead of calling it nitrogide, just scooch this over just a little bit here, we call it nitride. Ooh, doggone it. There we go, nitride. And below that is phosphorus. Phosphoride sounds silly, so we call phosphorus phosphide. Oops, and I messed up my spelling there a little bit. Phosphide, there we go. Phosphide. So what's the pattern here? Well, if you notice, all of these are group 17. All of these are group 16. And all of these are group 15. So to figure out what charge we expect off of an element, off the periodic table, when we are looking for an anion, when we expect a charge, all we got to do to find the charge, it is the group number minus 18, right? Because all these were in group 17. 17 minus 18 is -1. All these are group 16. 16 minus 18 is -2. Group 15. 15 minus 18 is -3. You got it, right? So, by the way, how do I remember that? That 18 is not just an arbitrary number, right? Where does that 18 come from? Well, there are 18 groups. And remember, this is another reason for the noble gases, right? They tend not to form negative ions. 18 minus 18 is 0. So all of these guys tend to not form anions. Just more evidence of why they're so noble and haughty. But if I wanted to look at, so for example, let's say somebody asked me, what would be the charge of carbide? All right, to give you another one there, carbide, right? What element must that be? Well, the only element that's anywhere close to carbide is carbon. And you can imagine if I drop the O-N and make it an IDE, then that's what I'm getting. I'm getting an anion of carbon. So let's write the symbol for carbon, which is a big old C. And carbide is a negative ion, right, it ends in IDE, so I know it's a negative ion. So to find that, we take the group number and subtract 18. So 14 minus 18, so for carbide, 14 minus 18 equals negative 4. So we'll put a negative 4 charge up here. So if you are asked to write the formula, or the symbol, I should say, for carbide, well, it's very simple. All right, that's negative ions, that's anions. Positive ions are a different story, right? So we're going to travel on over to the other side of the table here. Positive ions, right, are called cations, not cations, cations. All right, and the cations are mostly metals, although really any element can be a cation. That gets kind of tricky. But metals, and they are metals because they tend to be atoms that lost electrons, right? So there are two sorts of naming protocols here, all right? And it goes along with what you've already been taught for predicting charge, that last video about predicting charge. So we have the S block and the big three, as I like to call them. There are three elements on the periodic table along with the S block where you always know what the charge is, and so they are always named the same way. They are named by using the element name, and then you also add the word ion to the end of that. And there should be a space in between ion and the element name. So for example, I'm looking right over here to the right. There's sodium. Sodium is in group 1, and we're going to give it a Na+1. All right, so how do we name that thing? Well, that would be sodium ion. Right next to that is magnesium. Magnesium is also in the S block. It is in group 2, and so we call this thing the magnesium ion. Oops, magnesium ion. There we go. So what are you going to notice? Well, sodium is in group 1. Here, I got it right on the side here. So there's group 1. And notice it's got a +1. Let's try and write that a little better there. There we go. Group 1s all have +1s. Group 2s all have +2. That's nice and convenient. So now we're going to talk about the big three. All right. To talk about the big three, what we're going to do is we're going to go from element 11 to 12 to 13. Why? Because we're going in order, 11 to 12 to 13. This one was +1. This one was +2. So therefore, this one over here, I'm going to write on a slightly different color, aluminum is +3. If I know that one's +3, what do I guess this one is? Why, it's a +2. And then I go from +2 down here to this one is +1. See how they kind of form a reverse stair step? Those are the big three elements that you just kind of have to memorize. The charge on those three elements is always the same. Al +3 is always the aluminum ion, or if you're British, the aluminium ion. Zinc is always +2, and that is always the zinc ion. And silver is +1. It is always the silver ion. Easy enough for those three. Now we got to talk about every other element on the periodic table, because every other element so if we remember the S block, right? Here we got the S block, and those three elements, right? The S block has 13 elements in it. And then those three elements give us 3 more. That's 16 elements. All the other elements, all the other 102 elements, basically are going to follow this procedure in naming their cations. Because remember, sometimes you can have nonmetals behave this way. We'll talk more about that later on in the week. All right, so the name of every other element as a cation is the element name plus the Roman numeral. Roman numeral for the charge. Holy cow. So every other element, we will name their ions in this manner. This kind of makes things a little easier for us. Also makes things a little bit more difficult. So for example, Mn with a +2 charge. Doggone it. Mn with a +2 charge. What do we call that thing? Well, let's go back and we find, whoa, we jumped around a little bit there. If we go look for Mn, there's Mn right there, and it's kind of hard to see. I'll zoom in just a little bit more. We can see that that's called manganese. Manganese is right here. So Mn is manganese. And now, oof, man, getting some terrible drag on that right there. Now, to figure out what we put after that, we need to know our Roman numerals. Roman numerals. You really only need to know the first 6. Roman numeral number 1 is I. Roman numeral number 2 is what you say to your captain. It's I. I often write those like they're one symbol. Roman numeral number 3 is I. It's 3 captains saluting their, or 3 sailors saluting their captain, excuse me. Roman numeral number 4 is weird. It's 1 less than 5, so we write it like that. So in Roman numerals, if the small number comes first, you subtract it from the big number, and the big number there is 5, which is V. For 6, the I comes after the V because it's 1 plus 5, 1 more than 5. I'm going to write down 7 and 8 for you. You rarely ever use these, but I want you to have them as reference. 7 is 2 more than 5, and 8 is 3 more than 5. Some weirdos will write 8 like this, where it's 2 less than 10. But I think those people are weird, so I don't write it like that. All right, so manganese, we just said manganese is 2. It's a +2, so we need to put a 2 out here. I'm going to try and squeeze this right in here. So I always put mine in parentheses. Not everybody does that. Some people also put ion at the end of this, but I think that's unnecessary because you've already indicated that this is an ion by writing a Roman numeral there. This is even easier in the reverse, right? If I want to look at this and I want to do cobalt III, right, as the name of an ion, well, now I need to write the formula of that, so I need to find out what cobalt is. I go back to my table. There's cobalt right there. It is CO. So the formula for cobalt is, or the symbol for cobalt, I should say, is CO, big C, little o, or capital lowercase. And what we're going to do is we're going to take that 3, and that becomes the charge of the cobalt. It is a +3. And that's how you name ions and write their symbols.